Okay, this is a practice on finding the inverse function of a function. So you're given the function f of x or y equals x plus 1 over x minus 1. Now to find the inverse function, first things first, we're going to switch x and y. So I'm going to replace y with x, and wherever I see an x, I'm going to replace it with y. And now our mission here is to solve for the quote new y. So now we're going to do some more algebra. I have a portion, so I can cross multiply. So it's as if I have a 1 in the denominator. Now apply the distributive property and get the y's together on one side. So I can subtract y and then add x to both sides. Now factor out y. So I get y times the quantity x minus 1 equals x plus 1, and then in this case, solve for this y. So I have y equals x plus 1 over x minus 1, which is what we started with. So in this case, we say that this function is its own inverse. The illustration also verifies it, because a function and its inverse are symmetric about the line y equals x. So if this function is symmetric about the line y equals x, then it's going to be its own inverse. So when I graphed it, I got a vertical asymptote at x equals 1. That's where the denominators become 0, and have my horizontal asymptote at y equals 1. That's sort of a limit concept going on here. Because if I travel further and further and further over to the right, or further and further over to the left, forever and ever and ever, this graph will level off at the horizontal line y equals 1, but in this case, we'll never touch or cross it. And the diagonal line y equals x passes through the point of intersection of the horizontal and vertical asymptote, plus any point on this side of y equals x can be reflected and generate this point. So for example, here's a specific one. -1, 0, 0, -1.